Alright, so I want to talk a little bit about the middleware pipeline in ASP.NET Core, how it's composed. Primarily because ASP.NET Core is a little bit of a change from the traditional way that MVC applications and things were built, in that everything is composed through their middleware pipeline, whether you're using MVC itself or whether you're using static files within your application. It all runs through the same pipeline. So what is middleware? Wikipedia says it's described as software glue. Basically, it ties together different components of the application. It allows you to handle the input-output process of the application, modify that input-output as it goes through, and you can combine it to create a pipeline. A good example of middleware would be Microsoft's amazing blue screen to death. It sits in between you and waiting for the next reboot. What benefits does it bring to ASP.NET Core? One of the biggest benefits I feel is their composition approach as opposed to their abstract configuration. So if you've ever been through working with any of the old HTTP handlers and things in web forms, it was a lot of fun adding some things to your web config and going in and setting up the handlers. ASP.NET Core treats everything like that, so you're basically building all of the pieces into that middleware pipeline. Since it's composable, it's very modular. You can plug and play different functionality in there. You can pull bits out. You can rearrange them. Pretty much do just about whatever you want, but there are some drawbacks and some caveats to it. An empty ASP.NET Core application, by default, is just a shell. It's pretty much the same as a shell application. The only difference is it has a web host, which by default, at least in development, is going to use Castro. And that just creates a basic construction zone for you to start putting things together. If we look at the default pipeline that comes with an ASP.NET application, we'll see that by default it actually uses two pieces of middleware. The use developer exception page is a piece of middleware that is only going to be injected if you're in the development environment. That replaces the old ASP.NET error pages that showed all of the error messaging, etc. And even the app.run that's passed in as just an anonymous delegate is a piece of middleware that you put in there. We can support static files through middleware. Whether you're using, if you use MVC to add your MVC recipe using middleware, in this case, use static files, add support for serving static files from your application. There's a couple of different ways to add it. They have a use middleware method that takes a generic argument that takes the type of middleware you want to use. A lot of middleware will add extension methods to the application builder that lets you add the middleware. The core concept of the middleware is that you're constructing your HTTP pipeline. So when it comes to requests and responses, all of your requests come in, they run through all your middleware, all of your responses come back through your middleware the other direction. It's a little bit deceiving because it doesn't actually make two calls to your middleware, it just makes one entry. So sometimes it doesn't run both directions through the middleware because of that. Your middleware, each piece of middleware decides whether it's going to execute the next piece of middleware. When it's invoked by ASP.NET Core, it actually passes into it the context. It also passes into it a request delegate, and that delegate is a wrapper for the call to the next piece of middleware. What that allows you to do is modify that input data, that request data, and at any point you can decide to terminate the request and write to the response, return it, do whatever you want. So you actually don't have to execute the next piece of middleware. That makes the order important. A good example is the static file middleware. If you were writing your own piece of middleware that you wanted to compress images specifically, for example, if you did not put that in front of the static file middleware, then MVC is going to return those static files, and it actually terminates, does not execute the rest of the process, and your middleware will never execute. The benefit to that is that it makes the entire pipeline a lot more lightweight, but you have to kind of know what it's doing, so it creates a little bit of a black box inside as well. It can also be conditional. This is where it gets a little bit interesting. There are configuration methods you can use to say that specific paths are going to execute through one piece of middleware, and other paths are going to execute through another piece of middleware. And then those pieces of middleware can execute the next piece of middleware in the chain. A little more complicated in this path, and we'll see why in just a little bit. Simple middleware can be expressed as a method. You can create a method on any class as long as it accepts the right signature and pass it into your app.run, your app.use. In this case, what we've done is we've set it up two different ways. It's the same method, but we've used app.map and we've used app.mapWhen. The differences between those methods get a little bit interesting. App.map allows you to map based on a certain path within the application. So if they come in on a certain URL, you can have it go through a specific piece of middleware. There are some drawbacks to using map. For instance, you do not actually get, you get the app, and but you don't get the next delegate, so you can't actually execute the next delegate of the chain. MapWhen comes with its own set of drawbacks in that it actually branches the request and can actually prevent it from running additional middleware that's added. So, and I'll show you examples of that as well, because it can be a head scratcher. You can express middleware using delegates. In this case, in the app.use, we just pass a function and it takes the context of next. Context is the HTTP context that gets constructed, and next is the request delegate that writes the next request that's going to be executed. In this case, this allowed us to check to see if the request is HTTPS. If it hasn't come out in HTTPS, we're doing a context abort, and then we'll return to next. But in this case, when the context gets aborted, your actual request is going to get aborted, and the user won't actually get any content. Classes are the more common way to construct them. They're definitely an easier way to construct them because you can encapsulate them. They're a lot more testable. This is your typical middleware class. What's interesting about it is that Microsoft has taken the approach of doing it completely by convention. So you're not implementing any specific interfaces. All you're doing is following a specific pattern. You have a constructor that takes your request delegate, and then you'll have your invoke method or your InvokeAsync method, depending on whether you need it to be asynchronous. In this case, we're writing to the response stream, so we use the async invoke. The interesting thing here is if you look at what we're doing, if it's not HTTPS, we're writing to the response stream and we're just returning. Otherwise, we're calling the next piece of middleware. So that's a good example of the short-circuiting that I was talking about earlier, where a piece of middleware can decide not to execute the next piece of middleware. It can just end the process. It can write to the response stream. Where this does get a little bit interesting is when it first enters the middleware, the context that gets passed into it, the response is actually a default HTTP response. So what Microsoft does is tacks an HTTP response onto the request that's coming in and allows you to write to that and return if you want to. The one thing you have to be aware of, if you're calling next, by the time you get to the end, as long as the last piece of middleware calls next, it goes to a default no-op piece of middleware that creates an actual HTTP response. So it will actually replace the default response that's on there. So your execution order gets a little more interesting, and we'll look at that as well. The other thing this does, using the classes, simplifies our startup. Now we can just say use middleware, and we can put our piece of middleware in there. Middleware classes can take parameters. So if we want to take what name that we're going to write in there, we can take that as a parameter to our piece of middleware. The use middleware method supports that by taking an object array, a params array of objects that it then uses to construct your piece of middleware. The drawback to that is that it's not very intuitive. So you don't know what you're passing in, you don't know anything about the middleware, especially if you're consuming a piece of third-party middleware. So extension methods make that process considerably easier. And this is the way most of the middleware is constructed. They use extension methods so that you can strongly type the arguments, and then within the extension method, they just still call the use middleware. But in this particular case, our app.use IO middleware we know that that's a string getting passed in because IntelliSense will tell us that. Handling the request and the response. Middleware components function like a stack. So it goes into the first component that's registered, that component, then the next, with the difference being that each middleware component calls the next. So the way this works is that everything executed before you call next is considered part of the request. You call next after all the nexts have completed. Everything after the next is going to be part of the response. So you're actually handling request and response within the same method by chaining them together. So order is definitely important because it's going to essentially execute the responses in the reverse order that it's executing the request. Another important thing to note is that when writing to the response, depending on the complexity of your application, you should check to make sure that the response hasn't started before you do that. The reason for that is response can actually start streaming back to the client, at which point things like your context link headers are set already. And if that has happened and you attempt to write to the response stream again, you're going to get an exception.
Is there any way to prevent that? Is there any way to prevent that from happening down the chain?
No, not that I'm aware of. I'm just checking for it to make sure it hasn't happened. It's pretty rare. That's a Microsoft recommendation. I'm actually not even sure how to make it start streaming the headers back before it gets through the entire chain. Yeah, it's you kind of hedging your bets on what the middleware down the chain is going to do, but not always sure how that'll behave. Middleware is constructed once at startup. So when you call the use middleware, you pass your middleware in. In your startup, it will actually construct the instance of your middleware, and it puts that into the pipeline. And the only thing that gets passed down as it goes through that chain then are the delegates. This means that the dependencies aren't shared with the request. This can be a little bit of an issue because if you have a service that you want injected into your middleware that needs to be a scope dependency and you need it to be the same as what is on the request, you're not going to be able to do that easily because by default it is going to resolve it off the application services. So if we look at the way the dependency injection works in ASP.NET Core, there's three basic scopes that it uses. It's either going to be singleton, it's going to be scoped, or it's going to be transient. ASP.NET Core, the built-in DI container handles the lifetimes a little bit different than other DI containers, older ones that, such as say Unity. If you wanted to do something per request in Unity, you had to use their per request lifetime manager or build your own lifetime manager. It got to be a little bit of a pain. There was always HTTP specific stuff. Sometimes made it hard to share libraries between websites and other applications. The way the new DI framework works in .NET Core, it's shared between .NET Core and used in ASP.NET Core, is that it just has the basic concept of a scope. So when it creates that middleware pipeline, it creates a scope that's the same type of scope that it would create if you were in a console application. Then everything that gets resolved off of that scope is going to be scoped to the request. So that's how you end up with per request scopes instead of having to have specific things like lifetime managers.
There's a concept like a hierarchy.
There is. You can create a scope off of a scope. You can create a scope off of a service container. You can create subscopes. But it's just a scope. It's very generic in that term, so you don't have, it's not actually managing the lifetime, it's not looking at the lifetime of the HTTP request, because it creates it, it calls all the middleware gets done, and that scope gets made. So it's more just plain old code rather than specific applications. Configure services is called before configure, so all of your services are actually registered with the DI container. So we can update our middleware that we created and have it take a sample service engine. We can actually inject this service, but it gets a little bit interesting. One way we can do it is pull it from application services. This obviously is probably not a good idea. what application services does in your startup file is it creates a scope for the application itself. And then for each request, it creates a scope. Any service that you resolve off of application services without creating at least a temporary scope is going to hang around for the lifetime of the application. So what happens then is we end up essentially with a singleton that gets used for the life of the application, and it gets passed into each piece of middleware. That might be okay if it's not a stateful piece of code and you don't have to worry about it, but it doesn't allow you to share it with your request. One of the other things that you can do is create a scope off of your application services, which creates a subscope. This is essentially what the request process does when it makes requests, is creates these subscopes. Problem with this is you've got asynchronous things going on, you've got things that are going to be delayed, executed. It's not executed when it's created. Your piece of middleware is going to be executed with each request that comes in. And so when this scope gets disposed, that service that you just passed into your piece of middleware and when you created it, is going to get disposed as well, and you're going to lose it. But one way we can handle it is by passing it into the invoke or InvokeAsync method. So this is probably the best way to do it. If you're going to pass it into your middleware, is putting it into the invoke method. Now, you're going to get that instance passed in every time your piece of middleware is invoked. You can't cache it at the middleware layer or at the class level. But anything that gets passed into the InvokeAsync is going to be resolved during the course of the request. So these are actually going to share the same lifetime scope as the same service being passed into an MVC controller, for example. So that does allow you to get that scope served. There's another way that you can do that, and that's by actually using an interface. Microsoft has provided an iMiddleware interface. They actually have iMiddleware and iMiddleware Factory. Most of the time, you're just going to use iMiddleware. The only time you'll use iMiddleware Factory is if you're using a custom or a third-party DI container that has a different way of creating objects that are resolved. So then you have to provide a factory to actually instantiate those pieces of middleware. But in most cases, you're going to implement iMiddleware. And I said the most common way to create it was by convention, and then I'm talking about creating it via an interface. Interestingly, the reason it's misleading is it still gets used by convention. The middleware implementing iMiddleware, it's added to the application builder the same way, and you say use middleware, you pass your class into it, or if you have a different type of interface. The difference is that anything implementing iMiddleware, you actually need to register with your DI container. The conventional piece of it is when the pipeline goes through and executes, and it comes to that piece of middleware, it looks at whether the piece of middleware implements iMiddleware. And if the piece of middleware implements iMiddleware, then it resolves the iMiddleware factory, which there's a default one by default, from the service container, and uses that to resolve your middleware instance. So anything that implements iMiddleware is by default or automatically going to get resolved from the container. So you lose some control over that. It changes the way that your class looks because your class now can take all of your injectable dependencies in the constructor, and when it resolves that, it passes everything into the constructor. Now, that changes, since it changes the way it's constructed a little bit, because it's not only constructed once, it's constructed every time there's a request. So it changes your invoke and your InvokeAsync methods, so they will now take both the context and the request delegate into them, and they will no longer take extra dependencies. That all has to be done. The biggest drawback is you've now lost all the ability to configure your piece of middleware because you can't pass optional arguments into it. If you remember the previous example where we were able to pass arguments into the use middleware call, anything that you're using that implements iMiddleware has to be, anything that's in its constructor has to be resolved from the DI containers. So if you try to pass additional object arguments, you'll get a not supported exception. So it doesn't let you pass that in there. We can take a look at what our middleware looks like when we actually implement middleware. You can see the changes here. All I'm passing now is my sample service into the constructor. Now my InvokeAsync method is taking the context and the next delegate, and it's performing the same things it was before. Nothing else changed there, just where the pieces come from. Our startup class is updated too. This is one thing I found interesting, and I didn't have time to research it and find why. When Microsoft provides code samples and their documentation, even though they say that it's a scoped resource, your piece of middleware, they register it as a transient on the DI container. And at first I thought maybe that's because they're still only constructing it once per request, so it still behaves like a scoped item. And I thought maybe they're resolving it off of the base application services. But that can't be the case because the services that are passed into it are resolved off of the request scope. So why they do it that way, I don't know. I have tested it both scoped and transient. It works both ways. But there may be reasons that they have it transient. So I just kind of wanted to point that out. I don't know why it's that way. Why would we want to create our own pieces of middleware? There could be a lot of reasons. One that I look at, there's a really cool package called Blogifier. And if you want to see some interesting middleware at work, go look at the source code for the Blogifier package out on GitHub. It essentially adds a blog to our website. It's got entity framework with multiple provider support built into it. But one of the interesting things it does is it bundles its default themes within the assembly. So it has some custom middleware that goes in and resolves all of the files out of the assembly. They're all embedded resources. And the middleware itself, when they make calls for specific paths, it goes in there and it finds those resources and pulls them out of the assembly just as if they were objects on the disk. That's all just kind of done automatically. You don't have to write special custom handlers or anything to do it. CDNs would be another good example of something that you might want to do. So maybe you have a specific path where you actually want to resolve something from a network, or you're creating your own CDN, or you want to resolve something from a network location somewhere instead of directly in your site. So rather than having everything all mapped in the database, you can use your middleware to remap all your stuff to another location. Sky's the limit. Pretty much what you want to do with it. I do want to show you some pitfalls with doing middleware that I ran into in doing this as well, which get kind of interesting. So I'm going to go ahead and show you those real quick. Maybe once my mouse to it. So we talked about using map and using map when and different ways to compose that pipeline and how the pipeline can branch. That creates some weird behaviors when you're using your pieces of middleware. One good example is, I can just show you the default example. I'll show you what we, is it not presenting anymore? There. Can everybody read that okay? Do I need to make it a little bigger?
You go a little bit if you want.
Yeah, sure. How's that? So here we created a piece of middleware that's really similar to stuff that we used in our examples. In this case, we have created a map called grouped, and when you anything that comes into that path that is /group, it's going to return I am grouped. Anything that's not part of that path is going to go through our custom piece of I am middleware, which actually returns I am Dustin. We can look at that. It's pretty simple. It just calls a write async on the response and returns I am Dustin. Then we added a map when, and map when looks for name in the query string. And if the query string contains it, it actually uses app.use, which gets a little more interesting. In this case, we're passing to it both the request delegate for the next piece of middleware and the context. And we're calling next, and then we're writing to the response string. So if we look at this, the way it works, actually pretty simple. It just says I am Dustin. We call our mapped route. It says I am grouped. We add name equals Omaha MTG, and we get both things, Omaha MTG and I am Dustin. What's interesting here, if you take a look at the order of this, you see it says I am Omaha MTG, and then it says I am Dustin. This is an example of the flow of the data that I was talking about earlier, because the piece of middleware that outputs I am Dustin is actually registered before the piece of middleware that reads the query string value. That's just because it goes through that way in the request, and in response it's going to output the query string value first, and then it's going to run through our I am middleware. One place this starts to get a little bit interesting is if I want to run a piece of middleware, particular piece of middleware, after my map when. And if I were to try and run this after my map when, well, that works. Now I only get one. I get Omaha MTG, but I don't get the I am Dustin. The original piece of middleware still works. They just don't work in combination with each other. And the reason for that, and I'm not 100% certain why the design decision, but when you call an app.mapWhen, it actually branches the request pipeline. So even though I have app.use middleware, I am middleware down here, if it hits this route, even though this other piece is still valid, it follows that branch, that path, and it will never execute any of the middleware that follows it. So that can make configuration a little interesting because you may end up having to register middleware twice. In this case, you'll see I have an app and an app ref. The app ref is what gets passed into your mapping, and that represents your branch. So if I now come down and I add this same piece of middleware inside the map when, and if I were to rerun the same thing with the name parameter, now both pieces of middleware will still execute. But you have to have it registered within that branch. Some other interesting things. When I click my left mouse button. We talked about the order. We talked about the order of calling things, whether you call it before next or after next. A lot of that depends on whether you call next at all. If I'm not calling next at all, it doesn't matter. When I run this, it's going to give me my output that I expect. However, if I write to that response stream and then call next, and this actually happens to be the last piece of middleware that is registered. If I write to that response stream before I call next, and then applications actually go all the way through the request pipeline, when it finishes, it is going to replace that default response object with a new one. So if I haven't called, or if I'm calling next and I haven't written, and I've written to the response stream before I called it, my response actually gets written to, and then it gets replaced, and then it disappears. So you definitely have to make sure that you execute things in the right order. It makes for some interesting nuances. So as long as this same piece of code is executing after the call to the next delegate, it will work just fine. All right, and any questions? I think that's all I had. Yeah?
The branching scenario that you showed, if let's say that was in an MVC application when you use the default route at the end,
Mhm.
even that would not execute when it branches and so then,
You're talking about, so when I use a map when, and then you have
Yeah.
something underneath, so you
Yeah.
have like an app.useMVC?
yeah,
Yeah, your useMVC wouldn't execute. Your use static files wouldn't execute. Anything that's after that map when, you would have to put them inside that when block. There's some interesting nuances behind that. It gives you a new app ref, which represents that particular branch of the pipeline. And you can continue calling map when. You can branch that, and you can make a hierarchy, and you can make it as deep as you want. Most of the time, you're just going to be working with it in a linear fashion. But you can branch it if you need to. It creates some interesting hurdles that you have to get over. When I first did it, I beat my head on it for a while trying to figure out why my middleware wasn't executing, because I didn't see any reason it shouldn't be, and it's kind of what I figured out.
For troubleshooting that scenario, what sort of debugging tools did you go through to figure out? Is there something that showed up obvious in the?
I use one called Coffee, just works really well. Mostly I just set breakpoints in my middleware, and I said, what the heck's going on here? And actually every single one of those scenarios. In the map when scenario, I could see that my middleware wasn't executing. I could see that when I took it and re-registered it as part of that branch, it still executed. I can see why they did that, because they probably don't want it to follow a branch and then continue down the other path. And then you may have two distinct things: writing to the request, or handling the request and writing to the response. The whole issue of whether or not you're calling next and when to do that, same thing. Just set breakpoints, debug, take a look at it. You see that the response on there is the default HTTP response. And, you can see it being written to, and then you see that nothing comes back, is what it boils down to. When you have other pieces of middleware before it, it gets a little bit easier, because then you can set breakpoints in different places and see what the actual content is when it comes back, or compare patch codes or whatever you need to figure out that it's actually a different object. And I should take that back. I can't guarantee it's a different object. It is possible they just cleared the response, but I don't know why they would do that.
NuGet package. I assume this would be a common use case for NuGet package somebody out there wants to help you do whatever it is they're going to do, and create a NuGet package and register with the pipeline. That would just happen automatically?
Well, you still have to,
So do you
go in and introduce or whatever in there, but, yeah, and all that stuff will be in there for you. That's why I suggested Blogifier as a good example, because they have a couple configs you set up in there. You register their services, you call the use Blogifier or whatever the heck it is. I can't remember what it is. And there's a config you pass into it, and it configures everything for you. It configures your blog groups based on your HTML paths, or you can change some of that configuration. But it serves static files out of assembly resources, and it actually sets up several pieces of its own middleware in there.
Yeah, I was just thinking if it did register that method, which I guess that would get really super confusing.
Yeah, I don't think you'd want that, because then it becomes so much of a black box, you never know what was
Yeah.
going on with whatever NuGet packages you were doing. And you don't know how they're going to play together. Like I said, things like use static files that can short circuit and just return when it finds a static file. Here's a good example of why you may not even want to use the static files if you're doing something like, I maybe serving protected content. The static file middleware that ships with ASP.NET Core does not do any authorization or authentication. Authorization and authentication are all set up via middleware, but it doesn't matter where you put them in the pipeline, even if you put them before use static files. At least for authorization purposes, what those pieces of middleware do is they go in and they build out your user principal and your roles and all that, but the static file handler doesn't care. It doesn't check any of it. It'll just happily return whatever file you request. So if you need to do something like authorization on static files, you have to write your own piece of middleware to do it. Or in that case, you would probably do it on little paths. But
So it doesn't even respect the file security anymore?
well, if there's file security on disk, it will, but that's going to be,
Just put the file.
yeah. If the application's got access to it, it's going to return. It's not checking any of that stuff. The benefit you get to it, though, is that if you're serving static files, it's really fast, because all you're really dealing with is disk I/O. You put static file handler as early in the process as you can, and it's not running through any of those other pieces of middleware. It hits that and it returns. I saw an interesting question about ASP.NET MVC and ASP.NET Core in general. Somebody said, well, isn't it heavy? And the answer from the team was, it's as heavy as you want it to be, because you put it together, all the pieces that you put in there. Don't put anything in it that you're not going to use, and that's why the default, at least the empty application, has nothing in it. It basically stands up a Kestrel server and returns a string, and if you want to do anything, you have to start shuttling middleware in there.
Can you speak a little bit more why what scenarios you would choose an apple and not when then? What are you trying to accomplish with an apple and with the branching scenario?
Oh.
Is that to implement your security models and things like that, if I want to serve some content in security and some not? Why would I choose one of those?
Let me bring that code back down here real quick, and I'll show you. The signature is a little bit different on these. You'll see a map, and a map when your map is specifically going to take a path. Your map when is going to give you your context. If you just need to do something really simple based on a path, for instance, what I did, I just returned a string if you were hitting a certain path. One thing you might want to do is even redirect context. So maybe you're writing something that's just a really stupid, simple URL rewrite. So you move a blog, or you replace a blog package, and your URLs are the same except for a partial path. So you want to just do some simple rewrites and do that. I don't know why you would use rewrite rules for that, but that would be a good example of something you might use map for if you're doing it programmatically. Map when is a little more complex because it gives you access to not only the context, but then also the request delegate, so it allows you to continue calling additional middleware. Your map method is not going to allow you to do that. It's just a really stupid, simple, if they hit this path, do something. You can't continue down the request pipeline. I can actually demonstrate that, where that gets a little bit interesting here. In our startup, we'll get rid of this map when, and all we really have is our middleware that outputs my name, and then our map that outputs group here. And so we hit this thing at the default path, it outputs my name. When you call map, or when you hit the route where it has the map, it doesn't execute that other piece of middleware. It's just always going to return. There's no way to continue further into the pipeline. Map when allows you to derive some more complex scenarios because it allows you to start branching that request pipeline and run different pieces of middleware conditionally. So if you had a specific folder that needed some kind of special compression, you want to do image compression based on a certain folder or a certain request type that comes in or something like that, you could have it based on those rules go down that branch. But once you start branching that request, you have to start defining, you also have to define the map lengths for the negatives of that, or have it with in that map WAN have the rest of the pipeline in there as well.
So
In my opinion, it just makes things complicated, unless you have a really burning need to branch the request pipeline, it's probably not a very good idea.
So the comment, will suffice for both of them too.
In the most common case, I would just call the use middleware or create the extension method to do it for you. Because if you call map and you want to, if you have a, you have a use static files, and you have a use authorization, and you have a use MVC, and somewhere in there you have a .map. If that map gets hit, it's not going to continue running in the rest of the middleware. But completely depends on use case, and maybe that's what you want to do in some cases. So if you want something on a certain path to just really simply execute a piece of code, then that's the way to do it. I would still encapsulate it somewhere that makes it more testable. The delegate approach there, the anonymous function approach for executing it makes it really easy to demonstrate, but it doesn't make it very testable from an application perspective.
Just wondering if you've written any custom middleware, maybe what it did, or...
Says I am root.
Right.
I got that from your shirt.
I did. I actually did this first, and when I bought the shirt last week, I found it. So,
Or at least an example of something common.
I haven't. Primarily what I've done is just used other people's middleware. So, like the Blogifier example, using their configuration and things like that. So, I have a similar project that I'm rewriting my own blog for my own website, and I'm following a similar path to what Blogifier did, with some differences, but so I've been working on middleware to do that configuration as well. And, some of what it does is seeding the initial, some of the static database data, et cetera.
So if I understand correctly, the main purpose is something's coming in on request, and you want to do something with it,
Mhm.
or something happens and you want to modify the response.
Right. One example would be, let's say you want to put in a naughty word filter for forum postings or something, rather than necessarily having the logic inside. You may have shared logic that takes people's comments and saves them, but in some cases, like in this application, you're using a third-party product. Using a third-party forum application, it hits this endpoint, it saves the data, but you decide, hey, I want to filter out profanity. So you can stick that piece of middleware in there that says, hey, when we're hitting this API route that actually saves the data, we're going to inspect the request, and we're actually going to sanitize that data before we let it go through and actually hit the forum system. So it gives you the ability to modify stuff before it goes into even third-party components or after it comes out of third-party components in the response. And they don't necessarily have to be middleware themselves. They could just be MVC controllers or anything else. But yeah. All right, well, thank you very much. Thanks for that.